Hi, this is Mr. Cure. In this video, we're going to be looking at acid salts. So what I have here is a picture of baking soda. You might commonly have this in your fridge or somewhere in your pantry at home. And the reason I have this is because it's a great example of what an acid salt is. So an acid salt is something that has a metal, a polyatomic ion, and some hydrogens mixed into it as well. So let's look at how these work. So let's just quickly review what acids and salts are before we continue. So an acid is some kind of ionic compound that has hydrogen. So here I've got carbonic acid. We have a carbonate ion associated with hydrogen. So again, this be my acid, my carbonic acid. And here I've got sodium carbonate. So this is considered a salt. Now salt is really an ionic compound. It's not table salt. It could be any ionic compound. So here we've got our metal and our polyatomic ion over here producing a sodium carbonate salt. And what happens with acid salts is that a metal comes in and takes the place of one of the hydrogens in an acid. And as a result, you end up with this hybrid. So this has some elements of an acid. So that's why we refer to it as an acid. And it has some components of a salt. It still has the metal there. So an acid salt. So great example of an acid salt there. Now, what happens, well, before I forget, is when we name this, we have to have a special naming system. So what happens is when we write the formula, you always write down the metal first, just like we did before. Then you indicate how many hydrogens there would be. And then you'd indicate the ion that is present. So what we have here is we have a sodium hydrogen carbonate. So that's one way you can name this. So sodium, hydrogen, and the last part would be carbonate. Now, instead of saying all of this, a shortcut would be to say sodium bi. So bi tells you that there's only one hydrogen present in that particular acid salt. Let's look at another example here. So here, like before, we have acid, we have phosphoric acid, and here we have sodium phosphate salt. And let's say that, like before, one of the sodiums comes in and displaces one of the hydrogens. And as a result, you're going to end up with, you're going to end up with this particular compound. So like before, you write down the metal first. Now we've got two hydrogens, and you have a phosphate. So let's look at the name of this. So this would be referred to as sodium, because we have the metal first. Now here we've got two hydrogens. We use the prefix di, so dihydrogen. And then we'd include the last part, the polyatomic name, the ion. So here we have a phosphate. So here we have a sodium dihydrogen phosphate. There's no shortcut for this particular one. So let's look at what you have in your workbook. So again, the idea with acid salts is you've got a metal plus a hydrogen plus a polyatomic ion forming a compound. So you've got this salt and acid part. So you have called it an acid salt. So examples would be sodium. So where the metal would be sodium hydrogen carbonate, or you can have calcium dihydrogen phosphate. So again, you see that we have a hydrogen, and we also at the end have some kind of polyatomic ion. So here's another summary for you. So again, metal, if you got one hydrogen, you can refer to the hydrogen as hydrogen or bi, and then the name of the polyatomic ion. So for example, sodium bicarbonate or sodium hydrogen carbonate. Both of them would be okay. Or if you've got the metal with two hydrogens, use the term dihydrogen, and then you include the polyatomic ion. So you might have calcium dihydrogen phosphate. You'll quickly realize that dihydrogens only really occur with phosphates typically. So let's look at a little bit more detail at the bottom, how you'd actually write down the formulas. So here's what we have. I want to write down the formula of potassium hydrogen sulfate. So let's take a look at this creature. So with this, I'm going to write down the elements involved. I've got my potassium, I've got one hydrogen, and I got a sulfate. Okay. Now what happens is the metal is on its own, so you got a charge of 1, and then we look at everything here as a single ion. And I need to know the charge of this ion, so let's look at what's happening inside. So I've got a hydrogen with a positive charge, and sulfate has a charge of -2, or 2 negative. And then what we do is we look at the overall charge of everything inside the brackets. So it'd be 2 negative, and a positive gives me a negative. And then what you do is you simply cross over. So I'm going to crisscross, and we end up with 1 potassium and one of these bisulfate ions with an overall charge of 1. So HSO4. And there's my formula. The same thing's true over here on this side, but we're going to look at it underneath in a minute. Okay, so let's look at the bottom, just summarize what we've done. So I got potassium bisulfate. So what we did is we wrote down the metal, determined the charge. Then we looked at the ion in here, the hydrogen sulfate together. We have 1 positive charge, 2 negative charges, giving us an overall charge of negative. And when we crisscross, we end up with our KHSO4. Okay, let's look at what happens with a dihydrogen. So what I have here, very similar, I just make this smaller, is I've got iron, and it has 2 hydrogens and a phosphate. Like before, we're going to be looking at the charge of the iron. So here we've got iron 2, so 2 positive. Then we look at everything inside the brackets. Now here I've got 2 hydrogens. Each hydrogen has a charge of +1. So I'm going to have 2 plus for the charge here for both of them together. And the phosphate has a charge of 3 negative. So when you look at the overall charge here, it's 3 negatives, 2 positives, you end up with a charge of negative. So this dihydrogen phosphate ion has a charge of negative. Then, like before, we're going to crisscross. And when we crisscross now, we're going to have 1 iron, so it doesn't change. However, because the charge of iron is 2, we're going to have 2 of these ions. So we're going to have to put brackets around here, H2PO4. And again, we've got 2 of them. So again, what we did, just to summarize, we determined the charge of the metal, determined the charge of each of the parts of the polyatomic hybrid inside here, found the overall charge of the brackets, and then we crisscrossed to give us our final formula. So when you have a chance, try some of these out over here, and then pause the video right now and then check your answers. Take care.